Whenever I'm translating in algebra, I'm going to look for some key phrases. Let's begin by translating a few expressions. First of all, like I said, I'm going to look for some key phrases. So as I read the product is the first word that jumps out at me, and product I know means to multiply. So I know I'm going to be multiplying something in this expression. It tells me I'm going to be multiplying 12 and something else, and they get a little more complicated because it's not just 12 times a number, but it's the product of 12 and the sum of something else. So I'm going to be multiplying 12 by something that's being added together. The two things they want me to find the sum of are a number, which I don't know. So anytime in algebra when I don't know something, I'm going to use a variable, whatever letter you want to use. I'll just use n for the number. So I want to add n and -3 together. They want me to find the sum of those two things. So n plus -3. Now, going back to the beginning, remember I was trying to find the product of 12 and this amount over here. Hopefully that when we see this, we recognize that this is going to need parentheses around it to make sure that it's 12 times this entire quantity. Sometimes you'll see the word quantity used with these. So there's the expression. Notice there's no equal sign, no inequality sign. An expression doesn't have any of those. All right, next to this we have for less than. Less than is a key phrase that's going to tell us to subtract, and what you always have to be careful about when you see less than is that whatever you're taking less than of, like for less than, that's going to flip and become part of the end of the problem. So in fact, what I might want to do to start this is put a -4 down at the end of the problem. It always switches to the back. What I want to find for less than of is, here's another keyword. Trying to get a new color here. The quotient, that was not a new color. The quotient, which is going to tell me to divide something. So I want to divide 5. I'm going to use fraction to show division rather than divide symbol. So 5 and the square of a number. Again, I don't know what the number is, so I'll use x. Squaring something means to raise it to the second power. So there's the quotient part, the quotient of 5 and the square of a number. And if I want 4 less than that, then that's where that -4 goes. But notice again, it's at the end of the problem, not at the beginning. And we'll take a look at one more example down here. Notice they're asking us to find equations this time. Now we're going to start to see equal signs, or possibly even inequalities if we have an inequality problem. And the keyword that's going to tell you where the equal sign is going to go is going to be a keyword like is, or totals, or something like that. So as soon as you see that word is, that's kind of where your two halves of your equation are going to be. So let's go ahead and try to set each side up by itself and then put them equal to each other in this equation. So once again, I have that quotient. I'm going to be dividing something. They want me to divide 5 more than a number. More than's telling me to add something. And kind of like less than, I'm going to go ahead and swing that more than to the end of the problem. Although if you think about it, would 5 plus x be the same thing? Yes, it doesn't matter what order you add in. Subtraction does matter. But just to be consistent, I'll put that plus 5 at the end. So I want to find the quotient of this and 2, it says. So x plus 5 more than x, divided by 2. That's where that equals translates to. So now let's take a look at the second half of this sentence to get the second half of my equation. So is 3 times the quantity. Like we set up above, quantity is typically going to tell you to group something together. So 3 times a group of something. Once again, I want to find a sum, so addition. The sum of that number and 7. So the number we already used, which we didn't know, we used x for. So that number plus 7. And there's going to be my equation. Now, if I wanted to, I could go about trying to solve this, but they didn't ask me to, so I'm going to leave it as that, as the algebraic equation that sentence would translate to.